Hey. All right, so I want to talk about something that I've been meaning to talk about for a really long time, and that is that I think that we live in a computerized world, and I feel like I have proof. And also, I wanted to go into a couple of things on the internet as far as leading into how I think it's a computerized world also, and how you might find this very interesting. So let's get to it. I have a few things that I want to show on the internet. Let's see. And let's get this going.
The card quicker than just about any other industry on Earth. So watch fast. Electronic circuits have shrunk from miles of wiring to the size of a computer circuit board. And they're still getting smaller. An electronic circuit board is a computer component that can produce spectacularly realistic scenes. Animating this particular three-dimensional graphic took 4 months of work by artists and programmers with the aid of a G400 graphic processor by Matrox. A printed circuit board can be compared to a building composed of fiberglass floors, copper passageways, and stairs that link the floors between them. Cards are assembled with two technologies, surface wiring and wiring through the card. The components are placed into the holes and soldered in place. A stencil is used to apply soldering paste onto the card. This paste will solder the surface components. Here they place the stencil into the printing unit. It is through these holes that the soldering paste will run. The machine spreads the soldering paste, which contains, among other elements, a tin lead alloy. The printing blades go into action. They spread the soldering paste on the stencil. This paste runs through the stencil holes and covers the metallic surfaces of the printed circuit board, which will establish the electric current. Here is the difference between an unprinted card and another printed one. The unprinted card surface is much more shiny. Now they're going to install the surface wiring elements. They are automatically positioned by this rapid placement machine. About 36,000 components are installed per hour. That's about 10 per second. This incredibly sophisticated machine is equipped with a viewing camera that verifies the alignment and dimensions of each part before installation, and it unerringly positions the part at the exact spot. Another machine, slightly less precise than the previous one, installs parts where the space between two placement points is less than 2/100ths of an inch. It can install 8,000 parts in 60 minutes. The card continues on its way toward the oven, which accomplishes an essential operation. Once the parts are secured, the card goes into a convection oven, where the heat will solder the parts to the card. Different circuit connectors through the card are inserted into their respective holes. This operation requires great dexterity and is entirely done by hand.
All right. Now I want to show you another video real quick.
You might be wondering, how small are these transistors? Zooming in again and past the interconnect layers, we find FinFETs, which are transistors whose channel This chip has 24 cores, a memory to that of a Billions of nanoscopic transistors manufactured into a microchip the size of a tiny ant? Well, all these microchips were manufactured in a semiconductor fabrication plant like this one. Inside it is a clean room, which spans the area of 8 football fields and is filled with hundreds of machines, ranging in size from that of a van to that of a city bus, and costing anywhere between a few million and $170 million. Within this microchip factory, silicon wafers travel from machine to machine and undergo around 1,000 processes over a 3-month period. And at the end of production, each silicon wafer will be covered in hundreds of CPU chips, each containing 26 billion transistors. When we zoom in, we can see the nanoscopic transistors at the bottom and over a dozen layers of wires above. This integrated circuit is then cut out from the wafer and so it can be installed into your desktop computer. In this video, we're going to explore the entire microchip manufacturing process and show you how billions of nanoscopic transistors and an impossibly complex 3D maze of wires are manufactured in one of the world's most technologically advanced microchip factories. It's an incredibly complicated process, so stick around and let's jump right in. A portion of this video is sponsored by Brilliant.org. There are 2 sides to understanding how microchip manufacturing works. The first is the sequence of steps and processes needed to build the nanoscopic transistors and the labyrinth of wires. Whereas the second is how the semiconductor fab and multi-million-dollar equipment of the clean room floor work. And we'll be flipping between these 2 sides to get a complete picture. Let's start by opening up this desktop computer, focusing on the CPU and taking a look at what's inside. Here we have an integrated circuit, or die, which we'll refer to as a chip. This chip has 24 cores, a memory controller, a graphics processor, and many other sections. Within one of the cores, we can see its block diagram and the various elements. Zooming in on this multiply block, we find a layout of 44,000 transistors that physically execute 32-bit multiplication and constitute just 0.00017% of the overall 26 billion transistors in the CPU. Zooming in even further, we see
All right, so let's go further and check out another video. Let's see. Let's do this.
At Alienware, we're always working to improve how you experience your favorite games.
Lives and other videos. Have you ever wondered what's happening inside your computer when you load a program or video game? Well, millions of operations are happening, but perhaps the most common is simply just copying data from a solid-state drive or SSD into dynamic random access memory, or DRAM. An SSD stores all the programs and data for long-term storage, but when your computer wants to use that data, it has to first move the appropriate files into DRAM, which takes time, hence the loading bar. Because your CPU works only with data after it's been moved to DRAM, it's also called working memory or main memory. The reason why your desktop uses both SSDs and DRAM is because solid-state drives permanently store data in massive 3D arrays composed of 1 trillion or so memory cells, yielding terabytes of storage, whereas DRAM temporarily stores data in 2D arrays composed of billions of tiny capacitor memory cells, yielding gigabytes of working memory. Accessing any section of cells in the massive SSD array and reading or writing data takes about 50 microseconds, whereas reading or writing from any DRAM capacitor memory cell takes about 17 nanoseconds, which is 3,000 times faster. For comparison, a supersonic jet going at Mach 3 is around 3,000 times faster than a moving tortoise. So the speed of 17 nanosecond DRAM versus 50 microsecond SSD is like comparing a supersonic jet to a tortoise. However, speed is just one factor. DRAM is limited to a 2D array and temporarily stores 1 bit per memory cell. For example, this stick of DRAM with 8 chips holds 16 gigabytes of data, whereas a solid-state drive of a smaller size can hold 2 terabytes of data, more than 100 times that of DRAM. Additionally, DRAM requires power to continuously store and refresh the data held in its capacitors. Therefore, computers use both SSDs and DRAM, and by spending a few seconds of loading time to copy data from the SSD to the DRAM, and then prefetching, which is the process of moving data before it's needed, your computer can store terabytes of data on the SSD and then access the data from programs that were preemptively copied into the DRAM in a few nanoseconds. For example, many video games have a loading time to start up the game itself, and then a separate loading time to load a save file. During the process of loading a save file, all the 3D models, textures, and the environment of your game state are moved from the SSD into DRAM, so any of it can be accessed in a few nanoseconds, which is why video games have DRAM capacity requirements. Just imagine, without DRAM, playing a game would be 3,000 times slower. We covered solid-state drives in other videos, so in this video we're going to take a deep dive into...
Alright, now let's check out something else. Let's see. 5 and education.
video. To start, your smartphone has a variety of components that can do dozens of different things. And the brain at the center of all these components and functions is the System on a Chip, or SoC for short. When you watch a video such as this one, phone a friend across the country, or navigate through a city using GPS, it may seem like magic or alien tech. But in reality, these feats of technology are all performed inside this SoC, which is designed and manufactured through the hard work of countless scientists and engineers. In this episode, we're going to explore each section of this SoC and then piece together the processes the System on a Chip goes through when you do something as routine as snap a photo and post it online. These chips are unfathomably complex, as there are between 5 and 10 billion transistors that make up the SoC, and they all need to fit into an area the size of a penny. This is a complex topic, and there are many avenues that we could explore. But in order not to overload your brain with details, we've decided to focus on the following aspects. First, we'll start with a few notes and caveats, and then we'll dive into the layout and key sections of the System on a Chip. Next, we'll explore how data flows through the SoC, using the example of what happens when you take a picture. Then, we'll look at some of the complexity inside the Central Processing Unit, or CPU block of the SoC. And stick around until the end, where we'll discuss how scientists and engineers design and manufacture these microchips, and we'll explore what a nanoscopic view of the SoC would actually look like compared to this visualization. So, for this video, grab a snack, sit down, and maybe take some notes if you feel like it, because this is going to be one very thorough and incredibly detailed video.
All right. So, one more video. Let's see. Marriage education. Let's see. Let's do this. Does computer memory work? How do computer keyboards work? Drives, let's see. It's going to be in history. Let's see. Okay.
Time to help people customize and save with Liberty Mutual. Forgot my wallet.
Getting a fresh deal at Subway has never been easier. Just buy any footlong in the app, get another free.
The first computers used to be the size of an entire room. Then they were built to fit on your desk. The newest design is a portable device that sits on your lap. And today's laptops are made even smaller and more powerful. Its lightning fast and impressive graphics. This laptop is designed for high-performance gaming. The computer's brain, called the motherboard, begins as a printed circuit board. Its pattern of lines and pads in copper is the wiring for the electronic components that will be soldered to the board. This machine places a stencil of the component layout onto the board and applies solder paste through the openings. A quality inspection camera photographs the solder paste and sends the images to a computer. The computer analyzes them, looking for any missing paste, misalignment, or other mistakes. If the board passes inspection, it passes through 15 robotic machines, each of which places up to 150 components on the correct locations on the board in just 30 seconds. Then the board runs through an oven that melts the solder paste, connecting the components to the board. Another camera inspection ensures that the internal processor is correctly soldered and that no component is missing or shifted out of position. After function testing and a visual inspection, the motherboard moves to the assembly line and is set aside for the time being. Next, technicians manually assemble the top half of the laptop, called the panel kit. They place protection film on the 15-inch LCD screen. Then they plug in the cable that will connect the LCD to the motherboard. They insert the LCD screen into a frame, with the web camera and microphone already embedded. Then they attach this antenna bottom cover to the screen cover and position the motherboard cable inside it. Next, they install the module for the webcam and microphone. attach two hinges which connect this panel kit to the rest of the laptop. Then they install the Wi-Fi antenna in the antenna bottom cover. All components are concealed in the antenna bottom cover behind the antenna top. They complete the by pressing in a they assemble half of the laptop. First, technicians attach the top cover to the panel kit hinges and the touchpad. Then they install the right and left speakers in the top cover. Now the motherboard comes back into play. After inspection, a computer-guided router cuts out openings to accommodate the computer's fans, which prevent the electronics from overheating. A gaming laptop generates a lot more heat than a regular laptop, and therefore requires two powerful fans rather than one. After checking that the fan screws are sufficiently tightened, they place the motherboard into the top cover. Contaminants such as dust or oil can impede proper contact, so as a precaution, they clean the connectors for the memory modules with solvent, then dry them with compressed air. Then all the memory modules, the Wi-Fi and Bluetooth, and the solid-state which stores data. They connect a high-capacity battery to the motherboard. Batteries for gaming laptops are typically larger because the faster processor and dual fans consume more power. The last component is the keyboard, which fits into a rectangular opening in the top cover of the bottom half.
All right, so I just thought that that was interesting. I thought there might be a lot of people out there that might also think it was interesting. It's obvious that there's a lot of money being spent and a huge government out there that has a large interest in watching everybody, making sure that everything is being documented. And ironic thing to me is that there is no signs that they're watching us. And there's an extraordinary level of stupidity in important jobs. And so it seems to me as though there's a score being taken by everybody at all times, given any circumstance or situation. And as soon as they're done making phones as small as they can make them, or as soon as they're done building bridges or making buildings, I'm pretty sure that the day that they're done is what's considered Judgment Day. And then everybody gets their score on their phone along with an emergency broadcast system. So I guess what I wanted to bring to light was it seems like they're watching, and when things are really bad and you're like, why God? Well, it is sad, but God's planning on making a future where there's winners and losers. So if you are the victim, well, it was documented, and they're going to get shipped to another state or country, and you're going to get upgraded to a nice home with, all kinds of amenities. So there's a lot of things to take into consideration when there's people out there that are taking more and more out of life and wondering why no one's stopping them. Well, maybe it's just that they haven't stopped you yet. And for people that are just kind every day, because that's the way they were raised, well, maybe once they switch everybody around, there's an energy flux. Maybe you'll get taller, or you'll suddenly melt the weight off. Your brain will just light up and your energy will be through the roof. But I just kind of thought that was a little bit overkill, a little bit over the top as far as how far the government will go to make sure everything is being documented, everybody is being watched. There's a little bit more to it than just, making a computer. That factory they showed, that's an obsession. That's obsessing about Judgment Day, when as the government And I don't mean the government that we see on TV right now. I mean the government above that government. When they finally get to say, yo, fuck you. And I saw what you did. It's just not today.